Let's go over a few examples of using vectors. Consider an airplane that wants to fly 10 kilometers to the north in 1 hour. What it needs to do is to fly with a velocity of 10 kilometers per hour to the north. To draw the vector, I use a velocity coordinate system. The units here are of kilometers per hour. I draw a vector with length 10, indicating the magnitude of the velocity, and at a 90-degree angle indicating the north direction. I can name the vector whatever I want. It is reasonable to call it v with airplane over here, or just a for airplane, or just vector a for airplane where it is understood it's a vector of velocity since it's a velocity coordinate system. I'll use a. In case there's wind, the wind will push the airplane. Let's draw the wind's vector. Its magnitude is 2 to the left, or west because it is east wind. Notice I draw the vector twice. I can move it as long as I keep its magnitude and direction. Now if the airplane would try to fly north as before, it would get left to the point it wanted to reach. Notice that the vector t is the velocity that the airplane will have, and this line is also the trajectory it will have. So the airplane needs to try to fly a bit to the right in order to compensate under wind. To understand what's going on better, I sketch the direction of the airplane. Let's say this is the airplane. This is its nose. In the first case, the nose will point straight and the airplane will fly straight. But in the second case, the nose will point to the right, and by that the airplane will fly straight. Next time you see an airplane in the sky just above you and it's a bit windy, try to notice that. Next, let's take a ship that sails 10 kilometers at 35 degrees and then 25 kilometers at 90 degrees. Let's sketch it. S1 is the first part. Its magnitude is 10 kilometers. And S2 is the second vector at 90 degrees. The distance is just adding the two magnitudes of the vectors. In order to find the distance from the starting point, we draw a third vector pointing on the new position of the ship. Let's name it t. I mark the angle by gamma. This vector t can be built of two vectors, sx and sy, having sx plus sy equal t. The magnitude of sx is composed of two x components of the two vectors s1 and s2. The same logic goes also with sy. Now we know what is the new position of the ship, 8.2, 30.7 in kilometers units. To find the distance, we use the Pythagorean theorem. And to find the angle, we use trigonometry. So if you are at a jetty, you need to turn your fingers 75 degrees, and then you know that 31.8 kilometers in this direction is the ship.